apply to E especially. Okay, friends, so both Haney and DeWanda have put up the answer to part 1, so just correct your mistakes and make sure you got the same thing. Your independent variable should be your number of family members, and your dependent variable should be ounces of oranges. Okay, the graph, the best fit is A, and then you should have something along the lines of the more people in your family there are, the more oranges you buy. Okay, so I want to see some me too's. Who did that? Okay, Arthur did. Elijah, did you get that? Yep. Okay. Great. And then Brandon's going to put up the second one for us. So, and you may have noticed that these number patterns and number relationships are going to be coming up a lot this week. You had them, I think you had them Monday and Tuesday, so you're going to have them on homework. You're going to want to start really thinking about how... Why is it that the numbers that are divisible by 8 are also divisible by 4? Is it the same thing? Like, when I say divisible by 8, what am I doing? I'm just kind of narrowing it down a little bit more, right?
In this graph, what happens?
Right. What could you explain? Like, what would you say?
Because 4 can go into 8.
Yeah, so 4 can go into 8. So all of the numbers that are divisible by 8 are also divisible by 4, are also divisible by 2. And so, well, you kind of get to 2 anyway. Good. So, can someone read today's objective for me? Turn the page. Oh, go ahead. Students will explore rates of change, positive, negative, and constant. And we're going to go ahead and we're going to make a correction right away. And we're going to say things that have no rate of change. So I need you to write that down. Things with no rate of change. Great. And then go ahead and change it down here as well. Since it does not make sense to say a no rate of change, just cross out there.
So, Kareem, what word are we crossing out? Constant. And San Diego, what are we writing instead? No rate of change. Thank you. So, constant gets crossed off. And you fill in no rate of change.
Great. So a rate of change is the blank by which the dependent variable changes compared to the independent variable. What math word do we know that looks like rate? Raise your hand if you have an idea. It looks like rate. Julian.
Ratio.
Ratio. Exactly. So a rate of change is a ratio by which the dependent variable changes compared to the independent variable. Yeah, I'll right there. Okay. So let's think about that. A negative rate of change implies that as the independent variable increases, the dependent variable, what do we think? Like, decreases. Good. Good. And then a positive rate of change, or a hand this time, implies that as the independent variable increases, the dependent variable hands are good. Right. Increases. Good. Then for something that has no rate of change, that implies that as the independent variable increases, there is blank in the dependent variable. Raise your hand if you have an idea. change, exactly. So there is no change in the dependent variable. Fantastic. So a graph, so which axis is my independent variable on? Which axis do I usually graph it on? Which way does it go? This way or this way? Show me with your hands. This way or this way? The x or y axis for the independent variable. Cindy, okay. Jumanji's dancing. Right, the x. So as I increase for a negative rate of change, I decrease. So y'all should draw that. Okay. And then we're going to sketch a positive rate of change. So do that real fast, and then I'll do it, and you should. I see Elijah doing it right. Good job. Go ahead and sketch what you think a positive rate of change might be in that second sketch. Jane did it. Caitlin did it. Damani T is doing it. Giselle did it. Giselle did it. Good. So it's sloping upward, right? It looks like this. So what do you think this next one's going to look like? Brand. A straight line. These are straight lines. LSL. Horizontal straight line. Time out. I love what Elijah just said. This is fantastic. He said a parallel line horizontal line parallel to the x-axis. Fantastic. Not only did he use 3 math terms in one sentence, but he's absolutely correct, and that is a great way to think of it. So make sure you have these notes, and then we're going to move on. Got it? Put your hand on your head if you're all done. Good. All right, here we go. So here's what we're going to do now. I'm going to start us out with a point. I like the point 2, 8. I'm going to call it A. I need a volunteer to come up and plot a point that is going to show a negative rate of change between these 2 points. Jane, and everybody else should be watching what Jane does and be ready to plot the 3rd point. Okay? Because you might get sneak attacked. Great. Okay. So, good. We have 2 points. Clearly, as the independent variable increases, this dependent variable is decreasing. Which is exactly what we want for a negative rate of change. Now, Rashad, I'd like for you to come up here and plot point C for us. 2 conditions. It has to continue the negative rate of change, and it needs to be part of a linear, has to have a linear relationship with the other 2. Okay? You got it. Perfect. Great. So we see a negative rate of change. They have a linear relationship. And here's a clarification from yesterday. A linear relationship has to form a line. Okay? So that's going to make our lives so much easier. There's a line, right? So they're on a line. Therefore, they have a linear relationship. And there's a negative rate of change. Huh? Now, can anyone give me a scenario where this might be the graph for it? Think a second.
And you may want to have them talk, like see how creative we can get. Have them talk to their partner.
Yeah, you guys can talk to your partners if you want to.